Hello everyone, welcome to Synapse Physiotherapy Junction. Today we are starting with the kinematic part of the biomechanics. So what is kinematic? A set of concepts that allow us to describe the displacement or motion of segment without regards to force that causes that movement. For example, if there is a movement from A point to B point, we are only studying the movement from A point to B point. We won't study the force which we are acting from inside or outside of the body. There are total 5 kinematic variables. First is type of displacement, means whether it is linear displacement or rotation or combination of both, which is called general motion. Okay. Second is location in space of displacement, means it is on x axis, y axis or z axis. Direction of displacement means the movement is occurring in flexion, extension, counterclockwise, clockwise. It is called direction of displacement. Fourth is magnitude of displacement. It is range of motion. The movement which is occurring is measured in range of motion degrees. Okay, rate of change in displacement means the acceleration or deceleration part or the speed which the movement is occurring is called range of change in displacement. So first we are starting with the type of displacement. Let's start with the type of motion. There are main three types of motion: translatory motion, rotary motion and general motion. First is translatory motion. Translatory motion, also called linear displacement or movement in a straight line from point A to B at same time and same distance, occurring in a translatory motion. Means what it is telling, suppose there is a bone A and bone B between the joint. So one bone will move from this side and other bone will move on the other side. So do you recall any movement which is occurring this way? No. You can perform mobilization, but it is not a true movement. It is not done by the patient or it is not done by the person himself. It is done by the other person on someone else's body. So there are no true translatory motion available in the body. There is always some part of the rotary motion available in that movement. Now second is rotary motion. In rotary motion, there is a curved path motion of the body. Suppose there is a fixed axis center A and this is your leg. So from point 1 to point 2 to point 3, from A to 1, A to 2, A to 3, there won't be a translation of the bone in any way from upward or downward or above or below. Means what it is telling, that in true rotary motion there won't be a translation available. So do you recall any joint which can perform true rotary motion? No. Suppose this wrist is moving, so you can see the ulna and radius is moving downward and upward, and the wrist is also forming some translatory motion which is forming a rotary motion, but it is not a true rotary motion. Okay, there is no single rotary motion available in the body. Now third one is general motion. In general motion, it is a combination of translatory plus rotary motion. General motion is a combination of translatory plus rotary motion. Why? Because there is no single joint in the body which can perform pure rotary or pure translatory motion. So it has to be a general motion. Why? Because every joint in our body follows the curvilinear path. Means if any movement is occurring, there is some form of rotation or there is some form of translation. There is no pure rotary or translation motion available in the body. It follows the center of axis throughout the movement. For example, suppose I am moving this elbow to eat. Suppose I am moving this hand to eat. Okay, you can see that elbow is constantly changing its direction and changing its angle. So there is a change in the axis or center of rotation, which is called instantaneous center of rotation or instantaneous axis of rotation. So it follows curvilinear path. It is most commonly found motion or displacement type of displacement in the body. Second variable, that is location of displacement in space. So whenever we are talking about location of displacement in space, we are talking about axis and the planes. It is derived from the mathematical concept called Cartesian coordinate system. So the origin of x, y and z axis is center of mass, which is located at the center of the human body. So x axis is something which passes from the body from right side to left side. If I give the example, x axis is going from this side and coming out from the this side. Okay, it is this way. Okay, now y axis. Y axis is perpendicular to the x axis, perpendicular to the x axis, and it is also known as vertical axis. It is coming from upside to downside of the body. Now z-axis. Z-axis is something which we need a three-dimension diagram to explain. It is a axis which is coming from posterior side to anterior side. It is also called AP axis. Means z-axis is coming from back side to front side or front side to back side. These are the main three axes of the body, where x-axis is called coronal axis, y-axis is called vertical axis, and z-axis is called AP axis or anterior posterior axis. Second, we are going to talk about the degree of freedom for three axes x, y and z. If the segment or joint is unconstrained, means if there is no restriction, total 6 degree of freedom will be there. Means there will be 6 different kind of movement will be possible if there is no restriction at the joint. Biggest example of this is shoulder joint, where you can flex and where you can do flexion, extension, abduction, adduction, medial rotation or lateral rotation. Okay, and minimum there is 1 degree of freedom if there is some restriction. Now we are going to talk about the planes. To start with the planes of the body, we have to start like this. For x-axis, the perpendicular plane will be sagittal plane. For y-axis, the plane perpendicular to it will be transverse plane. And for z-axis, the plane perpendicular to it will be frontal plane. For example, let's start with the x-axis. Suppose this is x-axis. Okay, in this axis the plane will be perpendicular to it. This is sagittal plane. So the movement occurring will be flexion and extension. Flexion and extension. Now for y-axis, you know that the axis is vertical. The plane will be here, perpendicular it, and the movement possible here is this one. On the axis there will be rotation, so medial or lateral rotation. Now for the z axis, means the axis coming from back side to front side, the plane will be perpendicular to this, it is frontal plane. The movement possible here is abduction and adduction. Abduction and adduction means this movement. So that is how movement is occurring with respect to axis and the plane. Now the next variable is direction of displacement. Suppose you are watching wrist flexion from this side. You might say that movement is occurring in flexion in clockwise direction. But if you watching from this side, you might see that it is occurring counterclockwise. Both of the perspective are true, but in anatomical term, there is no clockwise or anti-clockwise. We will use some terminologies such as flexion and extension, which is occurring at x-axis and sagittal plane, medial and lateral rotation, which is occurring on y-axis and transverse plane, abduction and adduction, which is occurring on z-axis or ap-axis, also known as, and plane is frontal plane. Now, if there is a displacement occurring linearly, so if displacement is on this side, it is called positive. If linear displacement is on this side, opposite side, it is called negative, according to the Cartesian coordinate system. Next, we will covering some other topic, that is magnitude of displacement. So far we have covered type of displacement, location of displacement and direction of displacement. Now the fourth variable of kinematics is magnitude of displacement. You have seen there is a two type of movement, rotary and translatory. So suppose there is a circular movement or rotary movement, there is a circle which is always a 360 degree. But in human body, there is limited movement is allowed according to the joint or according to the segment, which is measured through the range of motion. So how do you define that? Magnitude of rotary motion that a body segment that moves through or can move through is known as range of motion. It is measured through the help of instrument called goniometer. Now other thing is electrogoniometer, and there is a thing called a systemic analysis of the motion, which we are not going to study in biomechanics obviously, but there is a thing, a goniometer and electrogoniometer, and which will help in computerized analysis of the movement. Okay, now this is about rotary motion. What about translatory motion? Suppose I am going in a linear direction from one place to other, there has to be some measurement which will be done in meters. If the movement is small, it will be measured in millimeter or centimeter. All these degree and meter, millimeter units are according to the international standard of units, which we will use in measurement of the displacement of movement, either it is rotary or translatory. Next is rate of displacement. So we studied magnitude of displacement. Now there is a rate of displacement. Magnitude of displacement is range of motion. Why rate of displacement is important? Suppose one person is taking 1 second for the elbow flexion and other person is taking 1.5 second or 2 second for the elbow flexion. Will there be a difference? Yes, there is difference of pure 1 second. So we have to study the rate of displacement for observing the change between the two person or one person's affected limb and unaffected limb. Okay, this is how clinically it is important. Now speed. Speed is rate of displacement. Speed is displacement per unit, but without direction. Means you will just measure how much it is covering the distance in some time. But Velocity is displacement per unit, but with direction. We have a stable body, so we need a direction to measure how much is affected, how much it is affected due to certain condition or without condition. So velocity is needed to measure the change occurring in the patient or a subject. Okay. Now what is acceleration? Acceleration is change of speed during particular time. Change in speed during particular time. Change in speed or change in velocity during certain time. How you will measure everything? First, velocity is measured as meter per second. Acceleration is measured as meter per second square. Angular velocity is if the movement is in circular, it is denoted as a degree per second. Angular acceleration will be measured as degree per second square. This is how each and every unit will be measured. Suppose there is a linear displacement, it is measured as meter per second because there is a change between one point to another, so meter per second. Okay, this is the main rate of displacement or rate of change which we are going to study in biomechanics. Thank you.